Welcome to doassignment-ca. Here is the problem. A weather station records the daily high temperature in degrees Fahrenheit and the number of ice cream cones sold at a nearby shop over 6 days. The data points are 68,42, 72, 58, 75, 71, 78, 85, 82, 103, and 85, 118. Create a scatter plot of the data, identify the correlation, and find the equation of the line of best fit using 2 reasonable points from the data. Then predict how many ice cream cones would be sold if the high temperature reaches 90 degrees Fahrenheit. Now let's work through the solution step by step. Let's organize the 6 data points. X represents the daily high temperature in degrees Fahrenheit and Y represents the number of ice cream cones sold. Looking at the table, we can already see a pattern. As the temperature goes up, the number of cones sold also goes up. This hints at a positive correlation. Here is the scatter plot. Each dot represents 1 day of data. Notice how the points rise steadily from lower left to upper right. That rising pattern tells us there is a strong positive correlation between temperature and ice cream sales. The scatter plot confirms a strong positive correlation. The data points lie very close to a straight line that rises from left to right, so a linear equation will be a good model for predicting ice cream sales based on temperature. To find the equation of the line of best fit, we choose 2 points that represent the overall trend well. Using the first point, 68,42, and the last point, 85, 118, gives us a line that spans the full data range and passes through the middle of all the points. Now we calculate the slope. Slope equals the change in y divided by the change in x. That's 118 minus 42 over 85 minus 68, which equals 76 divided by 17, approximately 4.47. This means for every 1 degree rise in temperature, about 4.5 more ice cream cones are sold. Using point-slope form with slope 4.47 and the point 68,42, we substitute and simplify. Distributing 4.47 times 68 gives 304.0. Adding 42 to both sides gives us the slope-intercept equation. Y equals 4.47x minus 262. That is our line of best fit. Here is the line of best fit drawn over the scatter plot. The line runs right through the middle of all 6 data points, hugging each one closely. This visual confirms that our linear equation is an excellent model for the data. Now we use our equation to make a prediction. We substitute x equals 90 into y equals 4.47x minus 262. Multiplying 4.47 by 90 gives 402.3, and subtracting 262 gives 140.3. Rounding to the nearest whole number, we predict that approximately 140 ice cream cones would be sold on a day when the high temperature reaches 90 degrees Fahrenheit. Let's verify our answer makes sense. The last recorded temperature was 85 degrees with 118 cones sold. Going from 85 to 90 degrees is a 5-degree jump, and our slope says each degree adds about 4.47 cones, so 5 times 4.47 is about 22 more cones. Adding 22 to 118 gives 140, exactly matching our prediction. The answer is reasonable. To summarize, the data shows a strong positive linear correlation. The equation of the line of best fit is y equals 4.47x minus 262. The slope tells us that roughly 4 to 5 additional cones are sold for each 1 degree rise in temperature. Using this model, we predict that about 140 ice cream cones would be sold when the daily high temperature reaches 90 degrees Fahrenheit. Visit doassignment.ca for more study tools, AI learning support, and online tutoring.